We have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find.
If it has an atmosphere, it is actually pushing up the temperature through the greenhouse effect above 0 degrees. And
now, President Biden has introduced the first image to be shown publicly from the James Webb Telescope.
The discovery of Proxima B in 2016 has captivated the minds of many scientists and space enthusiasts alike. Recently, the James Webb Space Telescope, the most advanced telescope in the world, was directed to observe this mysterious exoplanet, resulting in the clearest image of Proxima B ever captured. This breakthrough has left many wondering what secrets this image may hold. Could this distant planet potentially support life? The possibilities are both thrilling and endless. Join us as we explore the clearest picture of Proxima B that was just released by the James Webb Space Telescope. Clearest image of Proxima B. For a long time, people have been curious about the universe, and as technology has improved, it's only natural that humans would want to learn more about it. To explore time and space, we sent the James Webb Space Telescope into space, specifically to check out Proxima B. The James Webb Space Telescope is currently the most advanced one up there. It can see really far and is way better than the Hubble Space Telescope. This telescope helps astronomers study the early universe and figure out how galaxies, stars, and planets were born. Scientists can analyze the colors in the pictures it takes by using its camera and filters to focus on certain light colors. The telescope is also going to check out Proxima B and see if there are any signs of aliens. NASA, the European Space Agency, and the Canadian Space Agency worked together to build this telescope, but NASA's Goddard Space Flight Center is in charge of it, and the Space Telescope Science Institute runs its day-to-day operations. The JWST has a big mirror made up of 18 foldable hexagonal pieces covered in gold. It's way larger than the Hubble telescope's mirror, collecting more light and being super strong at observing different types of light, especially in the infrared range. To work well, this telescope needs to be really cold, below -223 degrees Celsius, so it doesn't mess up the infrared light it's trying to collect. They started thinking about this telescope in 1996, but it went through a lot of changes. After a big redesign in 2005, they finished building it in 2016. It's a $10 billion masterpiece named after James E. Webb, who was in charge of NASA in the 1960s. It was launched on December 25, 2021, from French Guiana. By January 2022, it was in its spot in space, about 1.5 million kilometers away from Earth. The first picture it took was shown to the public on July 11, 2022. The images it captures in infrared are like nothing we've seen before. The picture of Proxima B showed that the planet gets about 1,000 times more solar wind radiation than Earth, which makes it less likely for there to be life there because of the powerful flares. Proxima B up close. Proxima Centauri, a small red dwarf star, was already under investigation for planets before they found Proxima Centauri B. Early studies in 2008 and 2009 said there probably weren't big planets in the area where a planet could support life. This was interesting because usually small stars like red dwarfs have planets in that good-for-life zone. Then, in 2013, astronomers saw faint signs that the star was moving a bit, suggesting there might be a planet after looking for it for years. In January 2016, they started a project called Pale Red Dot to double-check if there really was a planet close to Proxima Centauri. In August 2016, scientists said they found Proxima Centauri B in the right zone for life around Proxima Centauri. They later named this mysterious planet Proxima B. Finding it was a big deal because it orbits the nearest star system to our solar system, called Alpha Centauri, which is about 4.2 light-years away. This means that when we look at it from Earth, we're seeing how it was 4.2 years ago. In 2020, scientists guessed that Proxima Centauri b is about the same weight as Earth, but they're not exactly sure. They also aren't sure how big it is. It could be between 0.94 and 1.4 times the size of Earth. Depending on what it's made of, it might have a big core like Mercury or lots of water. We don't know how far the planet is from its star, or how long it takes to go around it. Scientists used computer simulations to make educated guesses about the planet, but these are based on assumptions about things like the environment around it, heat from certain processes, how it spins, and the star's radiation. Proxima Centauri b probably formed under different conditions than Earth. It has less water and likely experienced more intense impacts because it's close to Proxima Centauri, but it probably didn't start there originally. The planet is thought to spin very slowly and always show the same side to the sun, a situation called tidal locking. This means some parts of the planet are super hot, while others are really cold. In 2022, they found another planet, Proxima Centauri d, orbiting even closer to the star. In 2020, there was a mention of another planet, Proxima Centauri c, but they're still figuring out if it's real. Being so close to their star, do these planets get affected? These planets are in the right zone for their star, where conditions could support liquid water. But that doesn't mean the planet is friendly to life. Being tidal locked with its star means it has an extreme climate. Any water near the side facing the star would likely get heated and evaporate, and the part in darkness wouldn't get enough heat, so all its water would freeze. Not a comfy place for potential life. Even though Proxima Centauri is much smaller than the Sun, its size makes its nuclear fusion cores closer to the surface, causing a busy and turbulent surface. This creates super strong magnetic fields that produce powerful radiation and particle bursts, which can be tough for planets in the star's habitable zone. Until recently, we didn't know much about the magnetic field around Proxima Centauri, but a new study using detailed magnetic field maps showed that Proxima b gets about 1,000 times more solar wind radiation than Earth. This puts any potential life at risk from strong flares. In April 2021, a flare from Proxima Centauri was 100 times stronger than any flare seen from the Sun. Surviving this intense radiation would likely require a special shelter. Proxima Centauri is about 4.2426 light-years away from our Sun, and is part of a star group that includes Alpha Centauri A and Alpha Centauri B, making a multiple star system. The gravitational forces in this system might cause Proxima Centauri b to get closer to its star over time. Proxima Centauri is usually too faint to see without a telescope, except in rare moments when a flare makes it briefly visible. Possibility of exploring Proxima b? Discovering a new planet or finding alien life in space would be really exciting. In late 2020, the excitement grew when a weird signal was spotted from the Alpha Centauri system. What makes it even more interesting is that the signal's frequency is 982.07 megahertz, not the usual frequency from Earth's satellites and spacecraft. This has made people more eager to explore Proxima b, and some ideas are being considered for the mission. Some of these ideas are ionic propulsion. This is the use of electricity to push a spacecraft forward. While it doesn't give a big push like fuel rockets, it can keep going and get faster for a long time. This method was used in a mission called Deep Space 1, which traveled at 35,000 miles per hour for over 10 months. But even with this, a trip to Proxima would take a whopping 81,000 years. Nuclear thermal propulsion. NASA is thinking about using nuclear reactions to heat up liquid hydrogen, creating energy like the sun, and using that heat to push a spaceship. This method could get a spaceship to Mars in 90 days, but going to Proxima b would take 1,000 years. Nuclear pulse propulsion. In 1946, Stanislaw Ulam, a scientist who worked on the atomic bomb, suggested this method. It involves attaching nuclear bombs behind a spaceship to push it. The spaceship would ride the explosion wave on a pad for safety. This nuclear pulse engine could make a spaceship go as fast as 5% of the speed of light, but it would be expensive and risky. Fusion rockets. This theory uses special pellets made of deuterium and helium-3. These pellets are shot into a fusion reaction, creating a super hot and charged plasma. A special nozzle controlled by magnets pushes out the plasma to make the spaceship move. This idea was used in Project Daedalus, and it's thought it could get us to Proxima Centauri in 36 years. However, since the concept is still new, we're not sure how to generate enough energy to reach Proxima B. Laser sail. They're getting ready for exploration missions like Breakthrough Starshot. It started in 2016 with Yuri Milner, Stephen Hawking, and Mark Zuckerberg. They want to make a super-fast, light-powered nanocraft called Starchips. These Starchips are set to explore the Alpha Centauri star system. They'll use powerful lasers from Earth to push a fleet of 1,000 Starchips to go really fast, about 15% to 20% of the speed of light. The lasers will focus on special light sails attached to the Starchips, giving them the speed they need to reach the target star system in 20 to 30 years. The plan also includes sending a message back to Earth, which would take about 4 years. Philip Lubin from UC Santa Barbara, who wrote A Roadmap to Interstellar Flight, explained that these lasers would need a whopping 100 gigawatts of power. That's like the entire electricity used by the United States, but it's only needed for a 10-minute burst at full power. The spaceship is a bit more than 10 meters wide and is expected to go incredibly fast, reaching 20% of the speed of light. It could possibly get to Alpha Centauri in just 22 years. But there are challenges. Gravity and stuff in space might slow down the spaceship. Even if it gets to where it's going, it would take 4 more years to send messages back to Earth. To keep it from melting, a special mirror reflects almost all the light that hits it. Breakthrough Starshot has clear goals. They want to show that super-fast, light-powered tiny spaceships can work. If it does, they plan to send these ships to Alpha Centauri, the star system next to us. These little ships could quickly fly by, taking pictures of any planets that might be like Earth. They also want to explore our solar system and find asteroids that could come close to Earth. If the launch system works well, they can send more probes without spending too much money. This means we might have a better chance of finding planets similar to Earth in nearby star systems. Looking for a phone case that can keep up with your adventurous spirit? Look no further than our JWST tough phone cases. These durable and sturdy cases are designed to withstand all earthly and cosmic hazards, keeping your phone safe and secure no matter where your explorations take you. So why wait? Click the link on your screen or the first link in the description to get yours today and experience the wonders of the cosmos with confidence and style. About exploring Proxima B, let's hear from you in the comment section. Also, make sure to like this video and subscribe to the channel for more, and we'll see you soon.